In today's video, we're going to be talking about the Thales Theorem under the enlargement and similarities. Considering the triangle we have here, triangle ABC, which is a bigger triangle, and a smaller triangle ADE. Under the enlargement and similarities, before you could find the scale factor or probably the unknown size, then you're going to find a scale factor which is going to help you to find the unknown size. And before you could do that too, then there's going to be an information of or indicating which of the triangles, either the smaller triangle or the largest triangle, is the image of the object. But what if you have a case where there's no information indicating whether the larger triangle is the image or the smaller triangle is the image? You don't really have any information concerning the image and the object. Then what are you going to do to find the unknown size? That's where the Thales Theorem comes in. And to apply the Thales Theorem in finding the unknown size of such triangles, then there is one key thing we should note. The Thales Theorem says that you can apply it, or it could be applicable, even only if we have the line here, DE, being parallel to what? BC. So from the triangle, it is clear that DE is parallel to what? BC. And if this condition is true, then in applying the Thales Theorem to find the unknown size of this particular triangle, then it is saying that AD, right, over DB should be equal to AE that we have here over EC. And this should as well be equal to DE, right, as we have here, over BC. So this is the Thales Theorem, right? Now, what if the triangle is of the same format, but you were not given information concerning the image and the object, whereas you don't really have anything indicating DE and BC being parallel? Then what are you going to do? You can still apply the Thales Theorem in such situations. So you're going to have A, B, C, D, E. And this time around, there's no information indicating that D is parallel to what? BC. So if you have such situation under the Thales Theorem, we could see clearly that we have two triangles, right? That is triangle ABC and triangle ADE. So what the Thales Theorem says is that in such scenarios, we should consider the larger triangle as what? Our image, right? Now, to do that, we're going to have AB as we have here over AD, right? So this side, we're considering the bigger triangle or the larger triangle, so AB over AD. And this should be equal to the other side, AC all over AE. And this should also be equal to, the BC and the D. Which one is the largest? Is the BC, right? So the largest should come first, BC all over what? DA. So that is when you don't really have any information concerning which of the triangles should be the image of the object, and you want to apply the Thales theorem in solving it. That is what you could do. Now let us also look at another aspect, which is actually the same as this first triangle. You see crystal clear that this triangle is, not truncated, right? But the DA and the BC are parallel. Then over here we have similar shape, which is also a triangle, but this time around this triangle has been truncated. If we extend this line and this line, definitely they are going to meet to form the triangle, right? But then it's been truncated. But once we can see that this shape is actually a triangle which has been truncated, but is having the AB being parallel to CD as well as the EF, then we can apply the Thales theorem to it. And looking at the previous one, we saw that the AD over DB. Then over here too, we're gonna follow the same procedure, that is AC. Okay, AC over what? CE. And this should be equal to the other side, BD over what? DF. So simply, this is how the Thales theorem is going to be. And with this theorem, we can apply it in solving a lot of problems under the enlargement and the similarities. So in our next video, we're going to be looking at problems or application of the Thales theorem. Thank you.